Yes. So, good evening to all the participants.
Welcome, Babu sir.
Yes.
Hi, sir.
Yes,
This is
let us proceed, sir.
we can proceed now, sir.
Yeah. Uh,
Good evening, everyone. I welcome all the participants to our workshop on AI/ML for Internet of Things. So again, today we have an industry expert with us. Before diving into our concepts and details of AI/ML IoT, we have an expert who is going to share his insights and expertise with us. So our speaker for today in the first half is Mr. Harun Babu sir, who is currently working at iNurture Education Solution Private Limited, Bangalore. Sir, on behalf of IIT Pune chapter, Buds Engineering Academy and Civic Incubation Center, I welcome you onto the virtual dais and I request you to please take over the session.
Thank you. So, good evening to everyone. Hope my voice is audible for everyone.
yes, sir, you are audible. Yeah,
Okay, sir. Okay,
yeah.
fine. So, I'll just share my screen. So, hopefully, it will be visible. I think so.
Yeah, it's visible.
Okay, sir. Okay, fine. So we'll go through the things before moving on to this session. First, I will go with some points. Before the sessions, previous sessions, I have been gone through all the sessions, and mostly I got an idea what are the sessions we have been seen before. Now it's a complete different thing because in previous sessions we have been more focused on IoT kind of things. What is IoT? And what is machine learning kind of things. Now we are going to a new thing called deep learning based learning. So this is one part of an AI concept. In an AI kind of thing, deep learning is one concept. So we are going to focus on what is deep learning. And second thing is what we are going to focus is how IoT plays an important role in deep learning. Second thing. And the third thing which we are going to say is how we can take one industry from an AI application, and we can see a practical implementation of the data and how we can proceed. So these are the three things which we are going to see in this session, step by step, and we are going to understand what is small things, because previous itself we have been gone through what is IoT and everything. So 2 to 2 minutes of what is IoT and what is machine learning, what is deep learning, these kind of things which we are going to focus. So this is the agenda of today's session. So next is directly I'm jumping into the AI application, because this takes to our next step what we are going to do and how we are going to explain the things. So here what we are going to say is what is the application, what are the application which we used in AI kind of things. Nowadays all 100%, 99 percentage, all the applications are based on AI kind of concepts. So this is the nature in every field, in agriculture, health, smart city, then industrial things, all these kind of things we are using IoT. Now, how this IoT is being merged with AI, and what is the scope of deep learning with IoT? Why it plays a main role whenever we are taking this all industries like agriculture, healthcare, then smart cities, or any industrial kind of thing, mechanical field. In every field, this IoT plays a main role nowadays. In past 2 to 3 years, this IoT plays a main role with combination of this AI, and especially with deep learning concept. So this is the thing which we are going to focus here. So now deep learning, so this is the concept which we are going to learn. So what is deep learning? First we have to see, right? Because previously we have been learned something similar about machine learning, but till now we are not started with deep learning. In some sessions we have been come up with what is deep learning. So I'll just give a small intro about what is deep learning. Okay, so I just added an image here regarding deep learning. Before moving into deep learning, we can take a small example, a small lifetime example. So whenever this deep learning or machine learning, this concepts comes into account, we can take an example of human, how human starts to learn. So this is the example which we can take. So how human starts to learn is by understanding something, by seeing something, by seeing some things we used to learn the things, by seeing something we used to learn the. So the seeing part, whatever we are seeing, our brain is started to function that, right? Our brain is started to function that, and we are getting the insights of all these things. So this is one point, right? We are processing through our brain. So likewise, this AI concept is nothing but the implementation of our things which we are going to do, in a manner that replica of human, the human, to reduce our effort, we are going for this kind of AI kind of things. In that, I'll just open my notepad. Okay, so we can see here. So the branch is like we are having AI, so artificial intelligence. In that, there are two different things. One is machine learning, which probably most of the person choose to talk machine learning, and next thing is deep learning. So these two concepts are there. So in this machine learning and deep learning, these two are a major branch of AI, a major branch of artificial intelligence. But what is the difference between this machine learning and deep learning? These two things used for helping the humans to reduce the effort and make an application. The final product will be an application. We are going to build an application using this ML or DL technology. So from as of now, I'm going to say like for machine learning ML and deep learning DL technologies. So what is the difference here? What is the difference between these two things? When it comes to machine learning, when we are going to focus on machine learning, it's moreover mathematical oriented things. Mathematical oriented things is comes under machine learning. When it comes to deep learning, it's completely a different form. Here, mathematics is not involved around 80 percentage. Only 20 percentage mathematics is been involved in deep learning. Now, the basic understanding of machine learning and deep learning, the difference. Okay, so the difference is when we are going for machine learning. Basically, I have been shown here one diagram. You can see here. Here one diagram. We are seeing one sec. So we can see here a diagram. We are having something called a input layer, hidden layer, and an output layer. So what is this means? Input layer, hidden layer, and an output layer is we have to understand this first. Whenever you are going to learn a machine learning or a deep learning, we have to need to understand this. What is a input layer? What is an hidden layer? And what is an output layer? Here I am taking that input layer as an input. Just I am going to take as an input. As I told, humans is being involved, and we are the persons who develop these kind of things. For us, whenever we started to learn, we used to see things. From that we get an idea, this is an object. If you're seeing an object from our small age, we used to see that, and we are going to have this is an apple, or this is an orange, or this is a dog, or this is a cat. So in case here, that is the input. Whatever we are seeing, that is the input, right? So here we can take input as a data. And finally, if you are seeing apple, we are saying that is an apple. If a mango is been showed, we are saying that as a mango. So that is an output from our side, right? That is an output from our side. Likewise, if you want to teach a machine, if we want to teach a machine, like uh, it has to show the difference between apple and orange. Has to show the difference between apple and orange. So if I'm saying showing to the machine, this is what is this, if I'm asking, it should say this is apple. Or if I'm showing this, it should say it's an orange. Like that we have to train the system. So for that only, first thing we need something called input, which is data, and it will say according to our input, it will say whether it's an apple or an orange. So two different things it's going to say. In between, here the next thing comes, we are having something called a hidden layer. So what is this hidden layer? What is this hidden layer? In the sense, this is the thing which going to process and teach the system to understand the difference between the apple and the mango, difference between the data which we are going to feed into the system. So basically this is called an algorithm, an algorithm which going to teach the machine what kind of input which we are going to give. So this is the exact idea. So now, using these three terms like input layer, hidden layer, and output layer, we are going to understand what is the difference between machine learning and deep learning. Once we understand what is the difference between machine learning and deep learning only, we can move to the next step. We can go with the process of deep learning. Okay. So when it comes to difference between machine learning and deep learning, I'll just show one thing. We can go with machine learning and deep learning. Okay. So here we can see two concepts. One is machine learning and deep learning. Both the things we are giving input as a car, and we are going to expect what is the output. The same thing which we are focusing, but you can see here in machine learning, there is something called future extraction, and it's been classified. And in deep learning, they have been mentioned like future extraction plus classification happens in one thing, in a one stretch. So what is difference here is when we are going for a machine learning kind of thing, we will be having one input layer. Our input layer will be one. Our hidden layer will be one, and our output layer is what are the output we are going to get, the probability 0 or 1, or 0 or many. So this is the output which you are going to get. When it comes to deep learning, its input layer will be 1. You will be having multiple hidden layers. We'll be having multiple hidden layers. So that is the first difference between this machine learning and deep learning. Machine learning will be having one input layer, one hidden layer, and one output layer. When it comes to deep learning, we will be having one input layer, multiple hidden layers, and one output layer. So this is the first difference. Before we are going to the future extraction, the first difference is you will be having multiple hidden layers. So what is mean by this multiple hidden layers? Why we are focusing on deep learning in industries? I'm saying in industries, whenever we are going for a textbook side, most probably we will be more focusing on machine learning kind of things in textbooks, algorithms, and everything. This deep learning focus is less. Why in the case is whenever we are going for a deep learning perspective, we will be most probably we will be using in industry kind of things. I will be explaining why we are, what are the things we are going to, how we are going to use deep learning and for an application, and how you are going to make that as a product. Every steps I will be going through. First we will see what is the difference between this machine learning and deep learning. Now I have been given some idea, I think so. Whenever we are going for machine learning, it's an input, one hidden layer with one input layer and one output layer. When it comes to deep learning, one input layer, multiple hidden layers, and one output layer. So here what comes is, what makes the difference between machine learning and deep learning is, we can take a small example. If you are taking a student, a first bench student, he is going to prepare an exam for we can take tomorrow is an examination. In the sense, he will start to prepare 3 days before or 4 days before. If you are taking a last bench student, he used to prepare 1 hour before or 2 hour before for the examination. So these two things applicable for machine learning and deep learning. Deep learning is a student, a first bench student, and the ML is last bench student. So I'm taking this example is it will be very easy to understand the difference between machine learning and deep learning. Why? In the sense, whenever we are going to deal with this machine learning, we need the output compared to deep learning. The output, the percentage which we are getting will be very lesser, very less. When we are going for deep learning, the output and the accuracy in the cases accuracy will be higher. The accuracy of the deep learning model will be higher compared to machine learning model. So that's why I told when it comes to a last bench student, max if he studies at the last minute, and that is the thing. What is the thing is he will be giving an input one question, he will be learning for one time, and he will be process the output. So the output will be very lesser. When it comes to a deep learning student, he is a first bencher. He started to one question he revised for 10 to 15 times. Likewise, the deep learning, the question, the input which we are giving is it will be learned for multiple times. That's why we are having multiple hidden layers, or we can say that as a multiple neurons. So that's why we call that as a neural network. We will be having multiple neurons. But what happens here is, why we have found the question arises, why we have to use machine learning and deep learning? Because machine learning is also in our subject, deep learning is also in our subject. If it gives very less accuracy, why we have to use machine learning? We can directly learn deep learning and we can process. So that is the bigger question will arise in everyone's mind right now. So the answer for that is, when we are going for machine learning, there is one constraint. Whenever we are going for deep learning also, there is one constraint. Deep learning performs good when we are having a big amount of data. We are having a big amount of data only, deep learning can give that much of output. If you are having small amount of data, machine learning will perform good compared to deep learning. So using a small amount of data, if you're feeding to deep learning, in 80 percentage of the cases, deep learning fail to compete with machine learning. One thing, whenever we are going for deep learning, if there is a big amount of data, if we are feeding to machine learning problem, the output will be very lesser. So this is the first two constraint which we have to focus. And machine learning, without machine learning we can't process any deep learning algorithms. Why? In the sense, as I told in the first itself, machine learning is like a mathematical perspective. We can understand the mathematical thing, how the data has been distributed. It's more over statistics. So what happens is, we will be in a industry, what we will do is we will start to collect the data first, then we will be using machine learning, we will be getting the insights of the data. Insights in the sense how the data has been, where the statistical informations, we can say that is a statistical information. We will be collecting the statistical information using machine learning, and using that we will be cleaning and processing. We will be doing all the data using machine learning. Then we will be processing the correct data, like the modified or data, pre-processed data to the deep learning model. So this is the difference. The here is, without machine learning help we can't go with the deep learning, because for deep learning the data should be very clean and pre-processed. It should be very neat and clean. Otherwise, deep learning model will not give an better accuracy. It will not give a good result. So that is the main problem whenever we are going to deal with deep learning. So the data should be very neat and clear. Okay, so now hope you have been understand the difference between deep learning and machine learning. Probably when we are going to talk about the algorithm, there are so many algorithms in machine learning. When we are coming to deep learning also, there are so many algorithms. In machine learning we have been two things, supervised learning and unsupervised learning. We are having two things. In that we are having so many algorithms. So right now we are more focused on our deep learning method. We will straightly jump into the algorithms in our deep learning method. So here, before jumping into deep learning algorithms, I will first need to make you understand what is data. That is very, very important when we are going for deep learning or any AI kind of thing. We have to understand what is a data. So anyone can get me through what is a data? Any idea related to data? Any one or two in chat boxes? What is data? Any insight? Data. If I'm asking, this is the data in a sense, any data. Okay, probably. Yes.
Participants should put queries in chat box if you want to ask. Uh, Sir, Dr.
Yeah.
Nitin has kept some query. Just see it.
Yeah, data is an input or a raw information. So yeah, so data is a input or a raw information. So here the data is a input or a raw information. In the sense, what we are going to see is it's like there is a information we need to extract, because we are saying that as a raw file, so we need to extract that. And I got another thing is it may output from any sensor. Okay, so that is also a good one. So what is, it's an output of an from a sensor. From a sensor we are getting a data. Okay, so I will come up with this sensor kind of thing next. Before that, it's an information which is in a raw format, which means in a data science term or in a data science field, what is mean by raw information in the sense we need to make that information understandable to the system. That is the first thing we need to focus here. First I will split this data information, so it's a raw information. So what kind of format that raw information is all about, because we are having an information in what format, that is the main question arise now, right? That is the main question arise now. What kind of format? Basically, there are some three kinds of formats are there. One is a image format. We can make it, we can save. Whenever we are going to collect any data, we can collect as an images, or we can collect that as an text format, text format, or any numerical format. In numerical format, these three different kind of things we can collect. So basically last 2 days before, we have been had a session related to NLP. In that NLP session, it's moreover the data is in the format of text, and image, probably we are using related to image also. Numerical is the part where most of the persons which fear to work on, because it will be in the numbers. So when we are going for industry perspective, we will be most working on the numerical. But I will first let you know there are three different kind of things. One is image, text, and numerical. These three different kind of datas are available. Okay, so here what we are going to do is I will go with image, text, and numerical. I will put text and numerical in one bucket, image in another bucket. Okay, why I'm doing this is in machine learning there are lot of algorithm we used to see, unsupervised, supervised. For supervised we have to use this kind of algorithms, for unsupervised you have to use this kind of algorithms. But in the case of deep learning, we are going to take only two algorithms and we are going to process. These two algorithms is the base for all the algorithms which we are going to see in deep learning kind of perspective. Okay, so when it comes to image, we will be dealing with only one algorithm. This is the base of all the algorithms, which is CNN. The full form of CNN is convolution neural network. So this is the base for all the methods. Okay, all the methods which we are going to use related to image. When it comes to text and numerical, we are basically focused on what we are going to focus is LSTM, long short term memory. So this is the algorithm we mostly focused on whenever we are going to deal with text and numerical thing. So this is the two algorithms which we will be mostly used in industry perspective also. This is the base. So all the code and everything will be the same for whenever you're going to deal with the data. Okay, so now we have been having an idea what is an input, right? What is an input? Input is nothing but a data. So the data is in different format: image, text, and numeric. So this is the thing which we have been seeing. So input, we are having a data which is image, text, and numeric. Then second part is hidden layers. So hidden layers is nothing but an algorithm. The algorithm which going to make understand what is this image, text, and numeric. So in machine learning, there are so many algorithms are there. In deep learning, we are just going to focus on CNN and LSTM. In this, CNN is used for image. CNN is used for image, and LSTM is used for text and numeric. So this is the thing which we have been seeing so far. Okay. Now the main important thing comes is how we are going to collect this data, how we are going to have this data, because it's an image, text, and numeric, and the data's definition is like a data is a input of raw information. So how we are going to collect that raw information, how we are going to process, because when we are seeing right now the examples we have been seen is we never seen what is the data, how the data is looks, right? So that is the thing. So here first I will show how the image data looks, because image data is very simpler thing. Today focus is on text data, in numeric data only, because probably most of the sessions is not related to numeric. I'm just going to focus on numeric today. Image and text, I'll just show the examples how the data looks. Okay, first thing. Before that, what we will do is we will just look into the picture of the process involved in this any machine learning or deep learning. In any machine learning or deep learning, these are the process involved. First thing, we are going to look into the big picture. Big picture in the sense, what is the problem we are going to handle, and we are going to get the data, and we are going to discover and visualize the data, and we are going to get the insights, and we are going to prepare the model for data for machine learning or any deep learning algorithm. So here we can mention like machine learning or any deep learning based algorithm, and we are going to train that, and we are going to tune, and we are going to test and getting the accuracy. So this is the steps involved in all machine learning and deep learning kind of works. Now what we are going to focus on today's session is we are going to focus on one application which is known as industrial automation using IoT. So this is the thing. So in every industry, in the mechanical field, how this data plays a main role, and how after this AI and machine learning started, how we have been processing all these kind of things. So this is the thing which we are going to focus, how automation helps in industry, how automation in the helps in industry. That's why right now we are in the era of industry 5.0, around 4.0 to 5.0. How this all happens, how we are going to use this deep learning kind of techniques in this industry automation. So this is the thing which we are going to focus today. So before moving on to that, what we will see is the data. First, we will take a small problem statement regarding one thing. So here we are going to focus on finding the remaining useful life of an engine. We are going to take an engine and we are going to predict when the engine is going to fail. So that is the task which we are going to see, and how the datas are there, how the datas are located, and we are going to see how we are collecting the datas from the sensor, what are the different kind of sensors are used, how the data looks. So because when it comes to IoT, IoT plays a major role in collecting all the data. We will be using IoT only, we will be collecting the data. So in chat box also I have been I told like it may output from many sensors. I got an reply like it's an output from many sensors. So the thing is, whenever we are going to deal with any industry kind of things, all the data are collected with any of the IoT devices, any one of the IoT devices. So that is the major task which we are seeing here, right? So here we are going to take this is our problem statement. Here what we are going to do is this is one of the aircraft engine. Actually this is one of the aircraft engine. Here we are going to focus on when this aircraft is going to the lifetime of this aircraft engine. So that is the description here, when this aircraft engine is going to fail and how we are going to find. So that is the thing which we are going to focus here. Okay, so that is the total agenda. Here we are going to deal with the numerical thing. Okay, we are going to deal with the numerical thing. Before that I'll just show the data first. Excuse me. So you can see here uh, it is difficult to understand this data because you can just see only numbers. It's just a numbers like some random time interval numbers. It's a time series numbers. So how using this we are going to process, because till now in previous things and all we can understand the data, but in this case we have no idea what is this data, because it's everything is just a numbers. We have no idea what this is numbers is dealing. How we have to first understand what is this data is all about. That is our first task. Okay, so what we can do is I'll just load and show this data. So first I'll go with the libraries which we needed for this. These are the libraries needed for this processing, and here I'm using the Kaggle, and the data is being stored in the Kaggle itself. So there is no need of downloading the data and everything. I'll share this link with you. Okay, so here I have been used the data train.txt. So this is the file which we have been open here. You can see here sorry, tm train. So this is the file which we have been open here. So the train.txt. So if I'm running this, you can see here I have been made the column. What are the columns which has been present? You can see its ID and the cycle in the sense the number of rotation. The number of rotation we can see in the engine, the turbine rotation, this turbine rotation. So number of rotations. Okay, number of rotations, and here we can see sensor 1 to sensor 21. So for analyzing this, we are using around 21 sensors. To analyze, to get a result, we are using 21 sensors. So what are these 21 sensor in the sense? Temperature sensor, proximity sensor, and pressure sensor, like this rotational sensor. So I can just show what are the things which they have been used. So that they have been used digital temperature sensor and humidity, pressure sensor, then vacuum, then motion sensor, like this. Around 22 sensors has been used in this one engine, and they have been performed and they have been collected the data. Okay, they have been collected the data. You can see here. So likewise this is something for testing purpose we have been used. So the same two kind. And here they have been given one thing called truth.txt. Truth.txt file. What is this truth.txt in the sense? I'll just open this. You can see just it's a number. It's just a number. So what this gives an idea about at what time it's going to fail, like how many rotations, how many cycle. Okay, the first cycle is around 112, around 112 cycle the engine is going to fail. Okay, so this is the truth data of when it's going to fail. So using these three things only, we are going to find what is the remaining useful life of that particular engine. Okay, the particular experiment. So this is the thing. So I'm just loading this also. So we are having all these things. Now we are going to the second step. The first step is we have been loaded our data set. Now we are going to do, what we are going to do is we are going to pre-process the data. We are going to pre-process the data. So this is the code where we are going to pre-process the data. You can see here, um, in pre-processing, when we are going to deal with the pre-processing, there are some things which you have to understand first. What are the main things is, one sec. Yeah, in pre-processing. Okay, in pre-processing there are some constraints because we are going to deal with uh, data which is a real-time data. This is a real-time data. First you have to understand what is the problems faced when we are collecting the real-time data. One problem is NaN values. NaN values in the sense we are using IoT devices. In some cases, there will be no backups. When the power goes, the sensor will not work. If a Wi-Fi or an internet issue, there will be lag of data. At that point or at that particular time interval, the data will be not there. So it will be filled with zeros. So that is known as NaN values. So, excuse me, whenever we are dealing with real-time data, we will be finding NaN values. So when you're going for pre-processing the data, first you have to identify there is NaN values in the data or not. That is the first thing. And the second thing is, uh, whenever we are going to deal with the data, we will be having all things like timestamp, because it's a real time scenario. By 9 o'clock it's been starting, we will be starting our devices, or we will be starting our IoT devices. In the sense, it's going to run for 24/7. In case if we can take like it's running for 1 month, if it's running for 1 month, we have to calculate, we have to go with this 1 month time period. So these timestamps are not needed for any deep learning or machine learning purposes. This timestamp is for our understanding. When it goes for machine, we no need this kind of timestamps. Okay, so we have to first identify for the data pre-processing step. We need to identify the needs of what are the things we need to put into the system, what are the things we are going to feed into the system as an input. We have to go with that first. That is the first thing. So what are the things is we have to identify the NaN values and important datas which we are going to feed as an input. Second thing, and third thing is insight insight of the data. Okay, so as I said, everything is a raw information. First we need to extract all these things. So this is the thing which we are trying to do here. You can see here there is something called drop. This drop is used for dropping the unwanted columns or unwanted rows, which mean here is, you can see here we are having an id, cycle, settings, sensor values. Here our main focus is sensor values. Our focus is not this id or a cycle. Id is meant by for that particular day they have been mentioned. For the day one, id 2, id 2. Likewise, every different companies or the person who is going to take a data, for their understanding they will be keeping different kind of things. So here we no need of this kind of things. We just need the sensor values when it's going to fail. This is our ultimate aim, and ultimate aim to get the output. Okay, so for that purpose what we are going to do is, we are going to drop the things which we doesn't need for our purpose, doesn't need for our classification. Okay, that is first thing. And the second thing is, as I told, you have to get the insights of the data. Insights of the data in the sense, the values, like what is the minimum value, what is the maximum value, when the rotation, like this and all comes into the field where we are going to work. Why I'm saying this is, when we are coming for this machine learning or deep learning, our major is different. Okay, you might be a triple E background, you might be a mechanical background, or you might be a computer science background, but our task, the work, the company which we are working will be related to any mechanical field, or any different field which our field will not suit. But we have to understand the data first. That is the main thing plays here. Okay, because we, as a computer science background persons, now we are studying related to something called a mechanical background, right? This automation, this AI and kind of things applicable for in all the fields. So that's why understanding the data is important first. Okay, so now what we are going to do is, we just made the things, we are just getting the insights of the data. Then what we are going to do is, same thing here, we are having two files, one is train file and test file. For train file also we are doing the same thing, for test file also we are doing the same thing, like removing and everything. Okay, now we are having a data with a pre-processed one and the things removed. Okay, we have been removed what are the things which we doesn't need it, right? All the things we are having, we are having the whole insights of the data. Okay, now what we are going to do is, we are going to implement that into one algorithm. So that is the phase, as I told, the hidden layer. The hidden layer, here we are going to use lstm as our algorithm. Okay, we are going lstm as our algorithm. You can see here, this is, what is this, I'll let you know. See here, here the inputs are like this. You can see around 0.63, in some cases 0.0, the decimal values and everything is different, right? Here you can see all the input has been converted into an array. So what is mean by this conversion? What, why we need to convert this kind of things? In the sense, when we are going to give a data to any machine or any algorithm, first we need to make understanding related to that. Okay, if we are seeing an image, we can say this is an apple or this is an orange. But for a computer, you should show as a numerical format, in a binary format, right? So you can see here, yeah, you can see here, this 7, this 7 is being made, and it's been converted as, what you can see here is, it's getting converted as a numerical format. Okay, for us this is 7, but for system 7 is something like zeros and ones, zeros and ones. Okay, we have to convert and we have to show to the system. So that is the process which we are dealing here. Actually, that is the process which we are dealing here. We are converting all that into numeric. format. You can ask like already it's in the numeric format only, why we have to change? Because see here it's in already in the numeric format only, why we are changing that into an array format? In the sense, in our data, whenever we are going to collect the data from a sensor, every sensor has every different units, every it will be saved in a different unit forms. All the sensors will not be in a single unit form. The unit which I'm saying is, for velocity some unit is there, for temperatures there some unit is there. So there are different kind of unit is there. So we have to change all the units into a single unit, and we have to process. So for that purpose only we are making all this numerics into an array format. Okay, so this is the thing. So whenever we are going to deal with any machine learning, this is not for this example, I'm saying for all the examples. Whenever you are going to work with image also, the same thing process goes on. Whenever you are going to work on NLP also, the same process goes on. You will be loading a data set, you will be reprocess the data set, and third step what will be you will be doing in the sense, uh, getting the insight of the data set, insight of the data set, and you have to convert into the algorithm form. In the sense, you have to convert that into an array form, then you have to pass into the model. So that will be your next step. You have to pass into the model. That will be a last step. If you're not converting this, and if you're passing directly into the model, there will be no learning and it will process with the error. So that is the thing going to happen. Okay, so now what we are going to do is, once it's been completed, the same thing for test also, we are going for the test also. Once it's been completed, we are building a model. Okay, so model in the sense, which what I'm saying is, in machine learning you have been come up with, for SVM we have been come up with some code, for random forest there will be some code. Likewise here, for deep learning, for LSTM this is the code. This never changes. This never changes in the sense, the flow of the code never changes if you are taking any problem statement. Okay, I will say why this code never changes, what is the main thing which changes, I will let you know once I completed this. So you can see here, we are just, this is the code for loading the data set, like passing the things into our system. You can see here we have been converted that into an array. You can see here. So this is a base of Python. If anyone knows, if everyone knows Python, it will be very easy to understand what are the things happen here. But this is the code. Okay, this is the code which we are going to see here. Once we started to run this, here I will make this as an one epoch. Okay, the model starts to learn. You can see here the model starts to learn the things which we are given as an input. Okay, in machine learning what happens is, whenever we are running any code, we will be not having this kind of epoch and everything. If you are running the code, it will directly go with an output of what is the accuracy and everything. But in the case of deep learning, here I have been given epoch one in the sense, I'm telling the system to, you learn for one time. If you are seeing, if I'm giving 3, you can see the difference. It's 1 of 3, it will go for 1. Why deep learning is tougher? In the sense, it will take more amount of time. See here, the one epoch is been we have been seeing here, the code is running. You can see here the code is running, the first epoch is been started to run. Okay, you will be getting an output. See here, once the one first epoch is been completed, you can see the accuracy is 90%, 94% accuracy. Okay, the loss is 0.23. So likewise what happens is, the system starts to learn the things, the input which we are giving. As I said earlier, it's like a first bench student, it start to learn again and again and again. You can see the second epoch, there is an improvement. You can see it's 96, the total validation is 98 percentage of accuracy. So next it will move for third one. So here the third point is it's went with 97 percentage of accuracy. So here what I'm going to tell us, this epoch decide the learning. Okay, if this, there is no problem. If the accuracy tends to increase, there is no problem in your learning. If the accuracy tends to decrease suddenly after 10th epoch or 15th epoch, you have to see such parameters. Like in the machine learning, you have to see such parameters related to deep learning. I'll be explaining what is that parameters and everything. But this is the process. When you are hitting this place, you are safe. You have been done all the pre-processing and everything in a correct way. If you are getting any error here, if you are getting any error here in this point, you have been done some mistake related to your data pre-processing, or the previous thing which you have been done in your data pre-processing, or converting your data into an array. Likewise, these different things you have to check on. Okay, so this is the major thing which differs from machine learning and deep learning. In machine learning, there is no concept of this epoch, running epoch wise and monitoring the model. But in deep learning, there is a concept, you have to monitor all these things. So this is the major difference between your machine learning and deep learning. Now the question is, what is the use of this epoch? Why we are using this epoch? In machine learning, there is no things like this. In deep learning, why we are having is, the machines tends to learn um, step by step. It will try to understand the difference of the data. If you're taking an image, it will start, if you're taking an apple and an orange as an example, it will try to learn each characteristics. The apple is in what shape, the orange is in what shape. Likewise, it will tends to learn all these different kind of things. So that's why it's going for different epochs. In each epoch, the learning will be different. But this epoch and this accuracy also depends on, it's also depends on how you are going to pre-process the data, how you have been pre-process the data. According to that only, this also decided. Okay, so there are so many aspects are there. I'm just giving the insights how these things are happening. Okay, then finally you will be having the evaluation. Okay, we are going to evaluate the model. You can see here, uh, only we have been run for 3 epochs. That's why the graph is looking like this. Okay, if you are running for 100 or 1000 epochs only, at the time only we can get an idea what is this whole things is about. Because if for 100 epochs and 1000 epochs, it nearly takes around 3 to 4 hours, and that time is not permitted. That's so that why I have been run for only 3 epochs in this case. Okay, then after evaluating, we are going to test the data with any, so you can see what is the accuracy, how that prediction has been happened. So this is the whole insight of the deep learning process, same as machine learning. But when we are going for that model, in machine learning we will be going for uh, any regression or SVM or any kind of things. But here we will be dealing with, as I said, whenever you are going for image kind of thing, you will be dealing with CNN. Whenever you are going to deal with any numerical or NLP kind of thing, you will be going with this deep learning, LSTM kind of things. So this is the difference between these two things, the machine learning and deep learning. This is one example related to um, automotive industry. When it comes to medical field, one example, with that example we will be having a good idea. So I am just going to show uh, the different example, a different data set. So you can see a data set here. So this is also, you can look like same, it will be look same like this. So this data set and this data set looks, probably looks same. So both are numbers only, you can see both are numbers. Here this is also number and this is also number. What is the difference here? This is an health related data set. Okay, so as I downloaded, I have an idea about what is this data set and everything. So this is a health related data set. What is this meant by? Here also the IoT plays a main role. You can just, I will show what is this data set is all about first. This data set is nothing but a human activity recognition. Okay, so what are the data set which I am showing right now? It's all about a real time basis. This all data set which we are using in the industry right now. Okay, so this is a human recognition data set. What this data set is all about is a person walking, sitting and standing. I'll just show this at the end. You can see, see here, if all this or there, a person is standing, we are saying the person is standing. Okay, these are the data a person is laying. So it's like from our smartwatch or any device, any IoT device which we are connected with our body, it started to taking whenever we are sitting this kind of uh, locomotory. In this medical term, what they will say is the locomotory motions we will be saying. So the locomotory motions, according to the locomotory motion, these are the patterns. If you are having these patterns, we can say we are sitting. If you are laying, we will be having this patterns. If you are walking, we will be having these patterns. So if you are walking down, the pattern differs. If you are walking up, the pattern differs. Like this, the data is being collected from an IoT device. So this is related to one medical field. So you can see it's a large data set actually. It comes with around 50 to 60 thousands of rows and columns. That's why I said when we are going to deal this with a machine learning problem, it will be very difficult because it comes around 70 to 80 thousands of rows. So it's very difficult. When the thing, when you're going to handle this, the same process which you have been done in the previous example, it's a different sector. That is a different sector. This is a different sector, right? So in this sector also, you can see here, we are just importing the data set. So we are just having the data here. We are just loading the data. Okay, you can see here, we are just going to do the pre-process. In last step, we have been come up with np.array, which we are going to convert into a machine understanding format. The same thing which we are doing here also. Then you can see here, this is the model. The same code there, the same code here lies. The model, this whole thing is for model. Okay, then we are just plotting the result, and here you can see the accuracy graphs and everything, right? So this is the same thing. Why I'm took this example in the sense, you are going to do the same thing for all your deep learning activities. It's not like machine learning. In deep learning, you will be having the same thing, same code, but the data differs, your pre-processing technique differs. These two things is going to differ in deep learning. The if using one algorithm, using this single algorithm LSTM, you can work on medical field also, you can work on industry field also, in automotive field also, or any agriculture field also. Using one algorithm, using one code, if you're changing the data, and if you're processing, you will get an output. But you have to concentrate on some parameters. So that's why I told 80 percentage of deep learning doesn't need mathematical understanding. Only 20% of deep learning method need mathematical understanding. Why I told that, in the sense, whenever you're going to perform any, you can take from any field like mechanical field or medical field. In any field you can take your problem statement, you can choose any algorithm, any one algorithm. Like in LSTM, you can take a standard version of that LSTM code. Using that code, change the data pre-processing steps and what are the things needed for that and what are the things you have to drop it. Just change that alone, you can get an output. And you have to see that this 20 percentage of mathematics, what is this 20 percentage of mathematics is, there are something called hyperparameters. So what is this use of hyperparameters? In the sense, this decide how the machine should learn. For a human, there are so many parameters. Like if a person has been in a calm environment, his mindset will be like, in two cases, in one case he used to study, or in one case he used to sleep, because the calmness make some persons to sleep, some persons to study. If it's an jolly environment, if a student who is going to study well, he will be started to study. If a person who is joyful and need to enjoy the things, he used to uh, play and go. So likewise, there are some parameters affect this accuracy level. So whenever we are going to see this code, only some 4 to 5 parameters are there that need a mathematical understanding very clearly. In machine learning, you need 80 percentage of mathematical understanding, because whenever we are taking any regression or anything, how the data flows, how the slope are there, how the data is being distributed, like this, so many constraints are there. But in deep learning, only 2 to 3 constraints are there. What are the things? In the sense, one is optimization. You have to know some 3 or 4 optimization techniques. So optimization technique is nothing but it's like an algorithm only. So here probably there are 2 optimization techniques we will be using. One is Adam optimization and next is SGD, gradient loss. We will be saying these are 2 optimization techniques which you have to study and understand what are the things. But when it comes to code, it's very simple. You can see here we just used optimizer equal to Adam. Okay, if I'm using here SGD, in the sense, if I'm using SGD in the sense, the program will start to run and you will be getting an output. But you have to understand what is the technique behind. You have to study theoretically what is SGD and what is the difference between SGD and Adam. So that plays an important role. When it comes to deep learning, the major thing is everything is very easy. You can start your coding in 2 days. But learning the theoretical background is tough, because if you're taking this code from anywhere and if you start to run, the code will start to run and you will be getting an output. But if you want the exact output, or if you want to fine tune your output, if you are getting 60 percentage of the 60 percentage as your accuracy, we need to develop that into 90 to 95 percentage or 99 percentage, which we are expecting. For that purpose, you have to study the things related to this optimization techniques. Like this is one thing. And the second thing is, you have to know the difference between the batch size and the epoch. What is batch size? What is epoch? What is this verbose? These small terms. Why I'm not explaining these things and all, in the sense, it's for one, this batch size, around 2 to 3 classes are needed. What is batch size? What is epoch? To know the difference, we need 2 to 3 classes. In deep learning, coding is very, very simple, but understanding the theoretical background and how you are going to apply in the code. Okay, just if you are studying epoch, in the sense epoch take 2 to 3 classes, but in the code it's just a term epoch equal to 3. When you're going for batch size, it's take around 2 hours to 3 hours to study the theoretical background, but it's just one line of code here. The same thing whenever we are going to study related to SGD, it's a single term, but it's take more single term, it affects the model performance. Okay, so here what are the things which we need to focus is main things: optimization technique, and we need to study what is batch normalization, second thing, and the third thing is batch normalization, optimization technique, and okay, then activation functions. So these are the three things which we need to focus whenever we are going to deal with this deep learning kind of things. Okay, so whenever you are going to study these three things, we can get a whole idea about what are the things are happening. Okay, here I will give a small idea about this. What are these things? What are this activation function and things? Before that, I will go with uh, the ideas or the things which we have been spoke till now. I will just go with a glance, then we will move on to these three things. It will be more easier, I think so. So first we have been seeing what is the difference between machine learning and deep learning. In machine learning and deep learning, in machine learning we'll be having one input layer, one hidden layer, and one output layer. When it comes to deep learning, we are having one input layer, multiple hidden layers, and a output layer. This is the thing first we have been seen. And we have been seeing three different type of datas. One is image, text, and numeric. This is the thing which we have been seeing secondary. And the third one which we have been seeing is algorithms. In algorithms, CNN for image, and LSTM for numerical kind of thing, which we have been seen as a third one. And we have been jumped into the real world concept. In that, we have been took two examples. One is industry, automotive industry, and second is medical field. These two things which we have been taken into account. Then what we have been seeing is the code for this both. Here I have been explained some 7 steps. One is loading the data first, and second thing is pre-processing. Pre-processing the data, and after pre-processing the data, what you will be doing is getting the insight of the data. You will be getting the insight of the data, and we will be converting to model form. Model form in the sense which I am mentioning here is the thing which we converted into array form, right? That is the third thing which we have been done. Then the model is started to learn. Here only we have been seeing something called epoch. Epoch is started to learn, and we are going for the testing and evaluating phase. So this is the thing which we have been seen so far. So here what I told us, just if you are taking a code, just if you are taking a LSTM code, just one simple LSTM code, then you are moving with different kind of data and pre-processing method, everything will be fine. While you are starting to learn, what are the things you have to focus? That is the thing right now we have been spoke, which is called the parameters, hyper parameters, which you have to focus more. So in that only we have been seen something called activation function and activation function. So this is one thing major. And optimizer, and the third thing is this epoch and batch normalization. These three things plays a main role. Okay, so I'll just go with a small insight of what these three things are. So activation function is nothing but, we can take this image. You can see here, this is an hidden layer I have been told, right? This is the hidden layer which I have been told. What happens here is, whenever we are giving an input, this all are called as neurons. This everything you can see, this is a neuron, this is a neuron, and this is a neuron. When input goes, when we are giving the input here, all the neurons started to pop up, all the neurons started to learn something. It will start to learn something. So in our case, this is a LSTM network. They started to learn. So here the mathematic comes. Here the mathematical part of the things comes. Okay. For LSTM, there is some mathematics, right? If we are understanding that mathematics, this will be easier. Okay. So what happens is, all the neurons started to learn something. So what happens here, this will be the thing, this will be our curve. Okay, this will be our curve. So activation function is nothing but, whenever we are having two things, apple and orange. For apple, the value is like 0.1. For orange, it's 0.2. In the sense, this 0.1, when the 0.1 hits, when the 0.1 hits, it will be saying that as an apple. Okay, when 0.2 hits, it will be saying that as an orange. Okay, this is the case. Okay, this activation function will lead to make this data, understanding this data, and the LSTM, using LSTM, the mathematics behind this will help this to make us 0.1 and 0.2. It will be make the difference, understand the difference, what is the ratio, the difference ratio between these two data points. So that is the thing. So activation function is nothing but, whenever you are starting an input, our data will be started like this, it will be going like this. So this will be our optimized value. When it hits, it should decide whether it should make the data into apple, or whether it should make the data into orange. So it's little bit goes into mathematics, but activation function helps whether it's to decide it should falls on class 1 or class 2. For example, it should falls on whether apple or orange. It decides the output parameter. So without activation function, we can't make a clear idea about what is this output, like whether it's an orange or an apple. So next is optimizer is similar to this activation function. Optimizer will help the data points to lie on this thing itself. For example, what happens is, we will be having like this, and our data points were like, this is apple in the sense, then this is orange, two data points which we are having. So this is the line. This is the line which decides the division of this. But in some cases, the model starts to learn. In the sense, in some cases, what happens, our data point will be very closer to this. Like here, this is apple and this is orange. In the sense, there is a very minimal amount of difference. Whether it should be classified into apple, whether it should classify into orange, will be doesn't know where it should classify. There only the problem happens, like where should it classify, right? So for that purpose, we'll be using this optimizer. Then epoch and batch normalization, in the sense, epoch is nothing but we have been seen it started to run, right? Here it started to run. It started to run. One epoch is, for example, if you are having 100 images, in the sense, if you are having 100 images, in that 100 images, how many images, all the 100 images has been trained, in the sense, it will be one epoch. Okay. If batch size is what, in the sense, if you are having 100 images in one epoch, how many set of images should be passed at an interval of time? For example, at first interval it should be passed 10 images, second interval 10 images, third interval 10 images. Likewise, all this 100 images passed in a 10-10 interval. Once all these 100 images are uh, completed, the cycle is completed, one epoch will be completed. Okay, so this is the whole process of this epoch and batch. This is the difference between the epoch and the batch. So when we are going to deal all these things, you have to just go with these three things. Once if you are mastered in these three things, deep learning is very very easy. Deep learning is very very easy. Think within 2 to 3 days of time, we can just copy code from anywhere and we can start to process. But if you want to achieve the accuracy what we needed, for that we have to study these parameters. All these parameters we need to study. For that, one best link is that, where for studying deep learning kind of concept, you can just go for deep learning medium. Typing deep learning medium, we can get into all the insights which I have been told today. We can get all the things what is deep learning. So the difference between deep learning and machine learning. So activation function, which I have been told right now. What is neural network? So what is training, testing? Like this we can go with. Other thing is, we can go with like this also. For example, you can go with, for specific, if we want to study about optimizer deep learning medium. So you can see what are the optimizers are present. So gradient descent. So this is the thing which I have been told. SGD. SGD is an optimizer. So there are so many things. So many things are there. This is Adam optimizer. ADA grade is an Adam optimizer. RMS prop is there. So like this, there are so many things which involve mathematics in this. So when we need a clear output, when we need a proper output, we have to study all these small details regarding our thing. So what we can do is, you can go with all these kind of things. And if you want to study LSTM also, you can use LSTM using medium. These are the study materials where we can get the theoretical background of whatever we studied right now. Okay, so hope you have been understood the process of what is difference between machine learning and deep learning, and how this process are all happening, how we can take a code, and what are the hyperparameters which we have to see. Hope everyone understood this. Any clarifications or any doubts? Okay. Sir?
Yes, sir.
Yeah, ma'am.
Yeah, yes, sir. One second.
Yeah, participants can put their queries in the chat box. Kalpana is saying good clarification. Anyone else? As luckily we got MD Arun sir from iNurture Educational Solutions Private Limited, Bangalore. And beautiful explanation algorithm. He has explained us one of the core algorithm for our machine learning, which deep learning. And he has given some hands-on experience for us. I think it's desired and required for us for our objectives. So I'm very much thankful personally to MD Harun sir, Babu sir, and
Thank you.
uh, over to Sai. First of all, any participants want to say something? Uh, Dr. Nitin, Kalpana, Madhuri, yeah, anyone want to say something? As sir is here, in future also he may take our queries, but as of now, if you want to say something, you can say it now here. Very nice, Vijaya, very nice presentation. Thank you, sir. Yeah, anyone else? Yeah, word to say.
Yes, sir.
Yeah,
So thank you
yeah,
so much, sir. We are really grateful for all the time that you've spent with us today, and thank you so much for sharing your insights and diving deep into the concepts of deep learning. We are really grateful. So once again, a formal thank you on behalf of IIT Pune chapter, Buds Engineering Academy, and Civic Incubation Center. Thank you so much, sir. We look forward for more such sessions.
yeah.
Thank you.
Very much. Thank you, sir.
Thank you.
Sir, just put off the camera. Let it be in the session if you are okay. Sir,
Okay, sir. Okay, fine.
actually,
Yes, sir.
session will end. Don't end the session. Okay.
Okay, sir. Okay, okay.
Okay. Thank you, sir. Thank you, sir. Thank you, sir.
Thank you. Thank
Sir, mail ID Kalpana is asking, is it possible to share
you. Yes,
mail
sir.
ID?
I'll just share the
Just
mail
put it in
ID.
the chat box, sir.
Yeah, I'll put it in the chat box.
Yes.
Yeah.
So after this, moving on, we are
One,
having a short quiz round.
one minute. Didi, Sai,
Yes, sir.
we'll have a continuation and then we'll see quiz round.
Okay, sir. Okay, sir.
Okay.
Okay, sir.
Let us have some discussion. We'll continue with the same topic again further. Yeah.
Yes, sir. Please continue.
Yeah. Yeah. Muhammad Harun Babu sir has already given a email, and a lot of happenings are happening with the iNurture solutions. The participants for further interest they can again. And again, luckily, we may have two more guests tomorrow and after tomorrow also. So we'll have a great treat for our learning journey. And you can approach directly to the sir also, and their company details also they will share in short later. Okay, thank you, Arun sir, once again. Okay.
Thank you, sir. Thank you, sir.
Yeah. Yeah. So now we'll see some our learning with our cloud computing. Some of the algorithm we'll try to see, and we'll also try to see what's happening in the cloud computing area. So here we have some research paper 2022. So recently what's happening in our area, because continuously that we have to see it again here. So first of all, we will see here what the market is talking about in this particular area, what the policies are there. So in the, you see what kind of cloud computing transactions takes place in your jurisdiction or some your areas. So you see here the almost all kinds of cloud computing transaction in region means you can see here the with public cloud services, software as a service, it can called as a SaaS. Here you can see, yeah, infrastructure as a service. I think cloud is one of the core area for our discussion. And then platform as a service, we can call PaaS. and all are the common. And all these segments, SaaS had the most market growth in the recent years, and private cloud models mostly adopted by different types of companies. And here are just first of all we'll see happenings in this particular domain in the industry. So the private, if you look for, you see the who are the global international cloud providers active in this. You can see here the most common provider operating in uh, Oracle, IBM, Microsoft Azure, AWS. Actually, these are the some of the providers for the clouds. And you can see here the Oracle, Microsoft, IBM, Azure. These are the providers for that. And if you look for the market size, that also we will see the market size. This is also one of the information. Now coming to the here the what the policy, some government policy for the encouragement of the cloud. Actually, this is basically some particular country domain, but just I have taken this for example as a reference, as a case study. So if you look for the case of Argentina itself, you see growth in software industry, you see it's too tremendous again happening in the recently also here. Similarly, yeah, I hope you understand the services available in the cloud over here. Now moving to the here just one diagram. You can see actually this is a paper. Actually, this is a healthcare. It's elsewhere. It is published in 2023. Means this year only this paper is published. These are the authors for that particular paper. But what we have to see is just we'll try to revise what's happening in this particular domain as on today. That's what the idea behind it. So if you look at here for this particular 2023, so you can see the here just I have paper. The healthcare industry generates enormous amounts of data, particularly in genomics, which require effective handling, storage, and analysis. Okay, so a lot of data is being generated in the all sectors, but this is one of the research paper the authors they have taken recently. This is in 2023. So which is effectively used for handling, storage, and analysis. I think storage we can understand, handling we can understand, analysis we can understand. Similarly, you can see here the cloud computing offers a promising solution to this challenge. So in cloud computing, the solution is we can handle the data, we can store the huge data, and we can analyze the huge data. That's what the objective of the cloud. That's what the challenge is. The solution is offered for this particular challenge. That's what the cloud. And here in this particular paper, you see the comprehensive conceptual framework for cloud computing adoption in bioinformatics. You see, the bioinformatics is again a new era for our learning, which can serve a valuable reference for practitioners, academicians or academics we can call, organizations transitioning to cloud-based bioinformatics service. You see, while cloud computing and bioinformatics can provide significant benefits to new opportunities in the healthcare, data privacy. I think just I am assuming that these are the terminologies you might be aware. Therefore, I am not explaining. But if you want to understand something more about the terminology, then we can see. But here you can see the healthcare, data privacy, and the security and management concerns are significant challenges that must be addressed. and organizations must implement robust security measures to protect sensitive partition information and ensure regulatory compliance. Regulatory compliance means some rules, and additionally, proper data management practices and training for healthcare professional are necessary to maximize potential of the cloud computing bioinformatics. Ultimately, the adoption of cloud computing in bioinformatics will pave a way for more personalized and effective healthcare. Actually, basically, this is one of the case study earlier. We have seen one what's happening, the market size and what the services they have offered. And in this research paper, of course, we will see little later again what they are trying to say. But here, just idea behind to take this paper in front of us for discussion is we'll get the what's happening today in this particular domain. That's what the idea. Now moving to the again, we'll come back with this discussion. But again, moving a little further, I think here, I think this my screen might be little visible, but I will try to explain you. Yeah. So some of the techniques used. So in that particular techniques in our particular domain, so one of the important thing which we have seen earlier, that's the AI, which we have studied it earlier in length. Similarly, the machine learning, which we are trying to discuss, as sir has beautifully, Harun sir has explained the deep learning algorithms, where some types of learning, supervised and unsupervised AI. I mean, actually, basically, these are the core techniques important for our discussion, like reinforcement learning. And also the just now the Harun sir has completed the one of the beautiful and most important core technique. That's what the deep learning, which is basically based on the generally the I think neural networks. I think most of the people may be aware of the artificial intelligence means one of the algorithm, that's the neural networks. And some this basically the terminology, if you look at here, the complex neural architectures can analyze patterns in data for tasks like image recognition. Means basically where it basically we are using these algorithms, image recognition, the audio processing. I think nowadays AI generated newsreader or something that we are already aware about that. So audio processing and even predicting device behavior, and convolutional neural networks, CNN we can call recurrent neural net. Actually, these are the some of the tasks is as sir has taken the core the deep learning. But this is what it's the techniques used here. But the as now we haven't much in our discussion as of now. That's what the computing. Now cloud computing, again we may discuss little later further in detail, but as of now introductory part, in the cloud computing, the edge computing, the fog computing. Actually, we have conducted earlier one program on that, the cloud computing, edge computing, and the fog computing. That everything will come under the heading of the cloud computing, the deep heading. You see here the you can see rather than sending all IoT data to centralized servers for processing. Okay, whatever data is being generated, which we are seeing in our discussion. So instead transmitting that data to the centralized server, edge computing involves performing computations closer to the data source. Means what we have seen as of now, the sensors will generate the huge data. You will find your data. And that data, the computing, the storing, as we have seen, the analyzing of the data, the storing of the data, or we can call it as aggregation of the data. That activity will perform on the cloud computing. But generally, if you look for the distance wise, this computers, this computing basically computing is nothing but the buildings of servers where we can store the data. That is a little away, not little, it's far away from the where data is generated. So suppose in particular industry is there, and in that particular industry, suppose, for example, as we have seen earlier also, 10 sensors are generating the data. So instead sending that huge data to the some centralized server, you try to pre-process that data at the field itself. It might be little closer. So we need not to transfer the huge data unnecessarily. So you can pre-process and sample, and then you can transmit that particular data. So you can see it here, the closer to the data source, and that source is nothing but the edge of the network. Edge of the network, just like our mobile phone, we are trying to transmit some data through some PSTN backbone network or some cellular site. So that cellular site, or the we can call it as a, in our GPS or GSM structure, the hexagonal cellular data and the base site antenna, and that will be transmitted to the again the some office or the regional office. That data is being transmitted. So in terms of network, just closer, or we can call it as an edge. So edge itself, we will have a processing capability. We may call it as a edge computing, as I underline the cloud computing, the edge computing, and the fog computing. So this is what the edge, only the word, the terminology. So compare, you need not to handle huge data throughout the network. So throughout the network, again, we can handle the little less data, because data generated from the sensors is a huge. I think you can understand what the edge. And AI models are developed on edge devices to analyze data locally. So some artificial intelligence models are being developed or developed. What that will do, that devices will analyze data locally and reducing latency and conserving bandwidth. As you might be aware of that earlier, I think I might have told you earlier that the Shannon's channel capacity theorem, that channel capacity should be greater than equal to rate of transmission. So if you want to transmit the huge data, means huge bandwidth is required. Suppose earlier we have a 2G generation, then the 5G benefits are not there, because the 2G, it will not support the larger bandwidth. Actually, it's a lesser bandwidth. So if speed is, if you want to transmit the huge data with speed, then we need a bandwidth. And bandwidth is one of the major resource in communication. So what this edge will offer a benefit for us is the less bandwidth will be required. I think conservation of the bandwidth means, suppose for example, we are transmitting the data over 10 megahertz channel or 100 megahertz channel. So instead you can have a bandwidth of 2 megahertz like that. So if you process the data, then 2 megahertz is enough. For example, just understanding, practically it might be different. Just I'm trying to give the difference, what the higher bandwidth and the lower bandwidth. And that's what the idea to generate AI model locally in the edge computing area. That's what the one of the technique used here in our AI IoT environment. Similarly, there is another AI technique which can detect usual patterns of IoT data, but of course that also we will see it little later. Also, there is one more technique in our AI, as we have seen. One is cloud computing. We are using heavily. Similarly, the NLP, basically the language processing, we can call it as a NLP. That is also hugely heavily we can call. So you can see NLP technique can be employed to process and understand text data generated by IoT devices. For example, chatbots, as we have seen earlier, and virtual assistants. I think if you open any website, then you will have a virtual assistant or something. So that is also one of the interesting thing. And also we can get it responded queries, providing more interactive experience. Similarly, there are some another AI model. Just we are trying to see some models. AI model can predict future outcomes based on historical data in IoT context. This can mean predicting equipment failures, energy consumption, and user behavior. For example, as huge data is being generated from the sensor and continuously data is being generated, so the AI models will predict future based on the past. That is called as a production. So generally, it is not a permission to see the hand or some. I think in our Indian environment, we come across some production. Everyone is interested to predict their future like that. But here, technically, the sensors will generate the data, and based on the past generation of the data and the predictive model, AI-based models, we can predict how much we can predict the when that device is going to failure, and what could be the life of the sensor which will support for us. That's what one of the example. Similarly, we can have one more example. For example, suppose for example, basically governments are struggling to provide electricity to all. So electricity or energy is a very big, because any development is directly proportional to the energy. So that energy, for example, in particular month, how much energy is required, or suppose summer, the energy demand, it may be in case of energy, summer energy demand may increase, or some rainy season, suppose energy demand may decrease because of some agriculture people, agriculture energy sector may consume less energy during the rainy season, and agriculture sector may consume more energy during the you can call it as a summer season. That's what the energy production. So next month after 1 year, or after 2 months, or after 10 years, what could be the energy consumption required for particular state or the governments. That's what the production models we can design with our AI. This is also one of the technique. Also, we can call it as a multiple. You see, here you can see the data privacy security. I think we have not yet covered as data privacy and security, but these are the major aspects we'll try to cover again shortly. Similarly, there is a data fusion is one of the technique. Data fusion. These are the some of, but the choice of AI technique depend on the specific IoT application and its requirement. Often combination of techniques is used to achieve the desired outcome. Means in our current scenario, we may not say that only NLP model is used, only cloud computing heavily we are focusing, or we are heavily depending upon the cloud. Like that, whatever techniques we have briefed over here, these are the few of the techniques out of which we are trying to understand one of the computing. If you look at here, as I mentioned you that the cloud computing, basically we need not to transfer the data to the deep servers or the clouds. So there will be network, the public PSTN network, or suppose BSN network and all. So at the entry point, or we can call it as the edge of the network itself, we will have some pre-processing or computing capability, or the data storing capability, or data aggregation capability. So that's what the edge computing. This is the one of the computing we have seen. So if you look at here, basically the edge computing is a decentralized computing paradigm that brings a computation, data storage closer to the source of data generation, often referred as edge of the network. And in traditional computing models, data is sent to the centralized data servers and cloud servers for processing and analysis. In contrast, edge computing aims to process data locally at or near the point of collection. This approach has become increasingly important with the rise of IoT devices, which generates vast amount of data that can be time sensitive and required. I hope you understand one of the important technique, what the cloud computing and what the edge. So I just tried to explain you the little difference, what the edge computing and what the train. So if you understand edge computing, the terminology as of now, if you understand, please say yes in the chat box. If you need more explanation, you can say no. So if you understand, you can say yes. I will be happy if respond anyone. Yes. Is it clear what exactly the cloud computing? As of now, we tried to discuss the terminology. Yeah, Kalpana is saying yes. Okay. Uh, the if you go for edge computing, the new terminology is coming up in the market. If you go for edge computing, the latency, the bandwidth, as I underlined earlier, the privacy of the data and the security of the data is also third important aspect if you get from this one. So basically, privacy and security means if instead transmitting huge data over the network, again, as I told you, the data is you see, suppose our data is with some standard names like Google and all, so people will trust them. But suppose people will hesitate to upload the data with some unknown server because we don't know about the privacy of our data. So the players like Google or Amazon, these people will trust them because people got assurance that these people, suppose our data is stored with our college or suppose educational organization, or suppose data is with server of the government server, suppose our this biometric or suppose Aadhaar ID server data. If the data is with the government agencies or the big companies like Google, Amazon, these people, so the people will trust, but people will try to think 100 times about the security and privacy of the data with the unknown names. That's what the idea behind it. So that also we will come up again back. This again we will come as time is running. So again we'll try to come back for that. But before that, just I want to introduce as time is running. So the little code for our cloud computing. So you see how data is being uploaded over the cloud. So you see some of the two, three functions we will see before proceeding to the cloud. So in Python again, we will need one library package. That's what the Boto 3. This is a package you can import, and then you can create a client. So that client, so you can use the function client function. You can see this is a client function, and once we have a library, desired library, and once we have a client function, then you can upload the your data. You can see this is a name of the data, this is a path of the data, and this is a file of the data. So you can upload data with the help of the upload file. This is a function, upload file function. I think we can understand the desired library is required to upload the data. So in few coming lectures, we will see practically how to upload the data on the cloud. But just I want to introduce right now the function used. So before going to upload our data, just as time is running, so we will see the one of the research paper again. This is a research paper. Basically, you can see this is a research scholar who talked about the cloud computing, and this is I think 2022. So here also you can see the abstract part also they have given, but important thing is he has explained about the services of the cloud as we have seen. So this is one of the service he has taken, he has concised. But here for that the SaaS service, you can see here the advantages he has given. The author has given these advantages. So you see, to provide SaaS, here just I will little bigger. To provide SaaS apps to user, you don't need to purchase. You don't need to purchase, install, update, or maintain any hardware, middleware, software. That's what the beauty of the SaaS. We will get it here. SaaS, we can call SaaS. We need not to have simply, that's one of the thing. SaaS makes even sophisticated enterprise applications such as ERP, CRM affordable for organizations that lack of resources to buy, deploy, and manage the required infrastructure and software themselves. That's what the cloud, the SaaS cloud will get. So anyone can shift easily to this to get the benefit of the this SaaS. I think this benefit it might be clear to you how he has already studied and he has kept in front of us. So he has published his paper in 2022. So that's what the information they have extracted in this particular paper in 2022. Means most recent information is this. Now moving to the user-free client software. This is again another benefit, SaaS benefit, our cloud, the SaaS benefit, the user-free. I think we have seen the definition. We have seen the AI technique. So in that technique, we have to understand one of the important technique is the cloud. In that cloud, the service available here is a SaaS service. And in this SaaS service, we have seen we need not to buy something. Just you can pay and use, or you use and pay, like that. Prepare or postpone kind of thing we can call. So here you can see the second important thing is the use free client software. Users can run most SaaS application directly from their web server without needing to download and install any software, although some app requires plugins. I think plug and play, that word you might be know. This means that you don't need to purchase, install special software for user. That's what the SaaS benefit the authors here are presenting. Similarly, the mobilize your workforce easily. Here, that benefit of the cloud server, the service SaaS, you can see the SaaS makes it easy to mobilize your workforce because users can access SaaS apps and data from any internet connected computer, mobile device. You don't need to worry about developing apps to run on different types of computers and devices because service providers has already done so. In addition, you don't need to bring special expertise on board to manage security issues, as we have seen the security issue. So you see the privacy is different and the security, of course, both are just like two sides of coin, but our data should be private, or the whatever data is others should not get hampered, or others should not modify our data. So some different framework is there throughout the world, just like one of the framework coming from European Union. That's what the F3 framework we can call. That's what the project coming up to ensure the privacy and the security of this data. Because you see, in one region or one under the control of one government, they can have some rules for to ensure the security and privacy. But whenever the data, you see the data, one end of the earth or the world and another of the earth. So many governments are, so many agencies, so many networks are involved. So it's very difficult for to have a control throughout the world on this particular issue of data and privacy. So of course, European Union, they have come up with one project. That's what the F3 project. And most of the member countries are signatories for that. So that's what the one of the initiative happening from the major players or industry players like IBM and other people. So they have come up with the security and the privacy of our information, especially as of now we are talking about the cloud. And similarly, they have given here the types they have underlined here in this particular paper. So in the type, you see our cloud. I think you can understand what the cloud is and what the cloud computing is, what the edge computing is. That's what the terminology we have seen, and what the AI tools and techniques, that also we have seen. As the Arun sir has underlined, very important technique, the algorithm, the deep learning, he has explained. So similarly, just we are trying to touch this one of the cloud service. We have seen the difference in the edge and the cloud and the computing capabilities we have covered earlier itself. As of now, just in the cloud computing, you can see the cloud might be public cloud, might be private cloud, or might be hybrid cloud. I think you can see it here what the public cloud is, what the private cloud is, and what the combination of this. You can see the public cloud and the private cloud. That's what the hybrid cloud. I think this might be clear to the type. Now, moving to the benefits of the cloud, uh, you see, it's one of the technique required in our domain. That's AI/ML and IoT, where huge data is being accessed or transmitted, and we can't transmit our data without cloud. So the cloud, if you go for the cloud, then you see, for example, I have to transmit my data or I have to get my real-time data. So it is very difficult for me to have an infrastructure. We have to spend trillions, me in the sense for major players, of course. It's very difficult, and the use you can see it's for 1 hour or 2 hour, and for that purpose we need to create the this much infrastructure. It's very difficult. So you can see if you have a cloud, then you can have the saving in the cost. I think cloud we may come across daily. So there is a huge saving in the cost, and also the scalability, flexible and scalability means we can call it as a demand on service, or I can say whenever in microsecond, every microsecond, suppose just like a time division multiplexing, it might be nanosecond or it might be time division multiplexing. I think you might be aware it might be in seconds or millisecond, or it might be some hours also, because sometimes we may use morning or sometimes you may use evening and so on. So that's what the scalability. So easily you can increase this. Sometimes suppose we need a more bandwidth, then you can access the more bandwidth if you want to transmit the data. If you want more time, then you can buy time, or you can buy a bandwidth also. That's what the flexibility, or we can call it as a scalability, depending upon our requirement. That's what the flexibility. And moving to the enhanced security. So if you look for the, as I underlined, what exactly the security issue is concerned, the government, the agencies, or some major companies, IBM, Google, Microsoft, these people, these are the trusted brands in the market, trusted brand in the market. So similarly, the AWS is one of it, the security, because people will feel secure for that. So this is what the idea, the proposed by here are the some department of computer science, some of the college, this university. So they have come up with this particular paper. I think as time is again closure, but quickly just I will just traditional and cloud-based healthcare architecture. You can see in traditional healthcare, you can see patient-related data, administrative-related data, financial data, public health research data, and that's what the data and data collected and delivered insights to the decision makers. Decision makers means, for example, some patient's health data is being continuously generated. So general people cannot understand the data, but concerned expert or doctor can understand and take the decision. That's what the decision making we can call. Similarly, the cloud is already embedded for the transmission of the data, and because of the cloud, you can see the data generated, clinical data, public health data, and all. And if you look quickly, as time is running, but this is again a recent paper. In this recent paper, this is especially they have taken example of healthcare as a case study for the cloud. So in this healthcare as a cloud, you can see the spendings, billions of dollars. You see in healthcare, these are the countries. This is the data as per the 2019. The US, China, UK, Germany, Japan. As you see the total how much billions the cloud computing spendings, which is in $1 billion. That's what the spendings. This is what the presently happening in the market. Now coming to the quickly the these are the few of the services you can have a software as a service. These are the some of the packages available here. Platform as a service, you can see these are the some of the players or packages. Similarly, infrastructure as a service. So this is the information tools or cloud-based service models. This is adopted. This data they have taken from this the 17 this is a paper this is a paper actually. So this is a cloud computing and healthcare and biometrics paper here over here. I hope I tried to explain you a little information about the cloud. But just for the closing, you just see the theme of the cloud, legal, technological, financial aspect. These are the cloud. So I hope you understood what exactly the edge computing, the cloud computing, and what the AI tools and techniques. In that techniques, one of the NLP framework or one of the AI framework, and in that one of the technique we have used is a we have studied is a cloud computing. In that cloud computing, we have seen the cloud computing and the edge computing, and we have seen the some situation in some countries as a case study, and also we have seen one paper we has they have published recently in 2023 recently, and also we have seen the they have taken one of the case study in this particular segment, that's healthcare, and in healthcare how much spending is there. So with this discussion today we'll stop it here, but before closing, I will be happy if participants have some queries for now. Yes, anyone has any queries right now? Participants can put their queries in the chat box. I think microphone is also unmuted. If you want to say something, you can say. Otherwise, we'll go for closing. I will wait for half minutes. Kalpana is saying no queries. Okay. If you have any general queries also, you can put. It is not necessary only for this particular topic itself. Okay, I think uh, Sai, you can close it now.
Yes,
Over to Sai. Just close it.
yes, sir. So thank you so much, all the participants, for joining. We will meet tomorrow at same 6 p.m. for the next session. So, sir, with this
Uh,
note, should I end the meeting?
yeah, yeah, go ahead. Yeah,
Okay. Thank you so much to everyone.
yeah.